Let's solve some more absolute value equations. When we are solving these equations, the first thing we always need to check is, are our absolute value bars by themselves? Is there anything to the left or right of those bars, on the outside of those bars, that we need to move over first? If the absolute value bars are alone, then we can split it up into our two cases and solve both of those equations. So in this example, 9 equals the absolute value of x plus 12. The absolute value bars are already by themselves. There's nothing outside of them that we need to move over. So let's split it up. Our first case is where we keep whatever's on the inside. We've got 9 equals x plus 12. Now to get x by itself, we're going to subtract 12 from both sides. So we get -3 for our first value of x. That's case number 1. We didn't change anything about this equation except we got rid of the absolute value bars. Case number 2, the 9 is going to stay the same, but we're going to negate that absolute value stuff. So now we have 9 equals negative quantity x plus 12. Again, you can distribute that negative to both pieces in the binomial, or you can divide by -1 first. I'm going to divide by -1, so then on the left we have -9 equals x plus 12. Then again, we're going to subtract that 12, and we get -21 for our other value of x. Now, if you're still not sure if you're getting these right, go ahead and evaluate by plugging in -3, plugging in -21, and seeing if you get back to 9. All right, next example. The absolute value of x minus 1 plus 14 equals 24. So this is where I was talking about how we need to isolate the absolute value first. So I'm going to start by subtracting this 14. That way the only thing I have is the absolute value. So we have the absolute value of x minus 1 equals, and then 24 minus 14 is 10. Now we can split it up into our two cases. Case 1 is where x minus 1 is equal to 10. Case 2 is where negative x minus 1 is equal to 10. And we're going to solve both of those equations. On the left, from case 1, we can add 1 to both sides, so x is equal to 11. On the right, we can either distribute the negative or divide by negative. I'm going to divide, so now we have x minus 1 equals -10, and then we can add our 1, so x equals -9. And those are the two x values that satisfy this equation. Let's keep on going. We have 4 times the absolute value of 6x equal to 48. This is still not isolated. We have this 4 out front that's attached to it, so we need to divide by 4 first. So now on the left, we have the absolute value of 6x equal to 48 divided by 4 is 12. And now we can split it up into our two cases. 6x equals 12, and -6x equals 12. Now on the left, we can divide by 6, so x is equal to 2. And then in case 2 on the left, we can divide by -6, so then x is equal to -2. And both of those values of x satisfy our equation. Absolute value of x minus 2 plus 8 equals 1. Here, first we're going to subtract this 8 from both sides to isolate our absolute value bars. So we have the absolute value of x minus 2 equals -7. Now this is the type of problem where we have an issue. If you think back to your days in geometry, distance is always positive. You can't go a negative distance. Absolute value is that distance from 0. So if you get an absolute value expression equal to a negative number, we have an issue. This is not allowed. Absolute value cannot equal a negative number. So, since that's the case, we say that there is no solution. That can be written as a 0 with a slash through it, or an empty set using these squiggly lines. You'll probably mostly see me use this notation, the 0 with the slash through it, but you might see this elsewhere. So again, if you have an absolute value expression equal to a negative number, you cannot solve for it.